Hi and welcome to Talk It Do It, the channel where we look to make tech videos that are more than hello world. In this video, I want to quickly show you how we can use Azure AI Agent Service using our own custom Python code to automate code reviews across multiple languages and also output interactive knowledge graphs like this. And as a bonus, I want to show how we can use Claude Code to update our agent code with a new language agent and run some tasks. This is currently in beta preview and will be exciting to watch how this develops. So how can we do this? We will use Azure AI Agent Service, which is currently also in preview, and of course write our own custom Python code where we build task-oriented agents that are ephemeral and destroyed after each job is finished. You can find links in the description. In this section, we will open the Foundry and also show you the playground. Let me show you quickly what the Azure AI Foundry looks like with some of the preview features. You can see the agent service, and in another video, I will explore the code review service. You can find links in the description. Let me quickly show you how we can use the playground to test prompt instructions without having to write any code. This is very useful when you want to test your logic and desired output from an agent rapidly. We have given the same instructions to this agent from our Python agent code, which you will see shortly, and we can see the expected output. In this section, I will quickly show you the custom code that we use to create, use and destroy the agents for language-specific tasks. As I am working on a video series, the code I use here will change, and this is just a quick look at the possibilities. I will share all the code once I have finished the upcoming series. The language agents class is our core component with 3 key methods, and you can see the instructions for each agent. Detect language determines the programming language. Create agent spawns an AI agent for each language type. Choose your model. Iterate through the file types for reading and preparing. The knowledge graph class handles visualization with the following methods. Add relationship creates connections between resources. Visualization graph generates graphs and creates an HTML page. Environment variables are stored in a .env file. The main execution process firstly initializes our AI project client, then creates language-specific agents as needed. You can see the documentation agent with its instructions to generate the documentation and visualization from the other agent's output. And this is the final part of this current code, where we use the threads and messages and then save the final documentation in our repository or directory structure. In this section, we shall delete the files previously created and rerun the process so I can show you the files get created as expected as part of the AI Agent Service process we have built. To begin, we run the createagents.py file to start our process. I have sped up this part of the process for the video, but you can see our agents and threads being used for each file type we have. Files are created and agents deleted. Now we can go and check the results and view the knowledge graph that our agents have created. We can see the markdown report that our document agent has created from the output of our other agents for cross-language analysis with a nice executive summary. It has analysis and comments for Terraform, and here is TypeScript as well. Good to see this level of detail from our original instructions for the agents. And here is the Python analysis, again with good detail. We can change instructions to suit. This is just a quick example. Here we see the knowledge graph as an embedded image, but here we see the knowledge graph as an interactive page. This is a basic example and we use PyViz, but Neo4j is something to consider too. Even though we use disposable job-specific agents, we can still see the previous threads in the AI agent service. Here is the output of a job we ran before, and we can see the output details. It would be good to explore how we can use these thread histories for work tracking and improving behaviors of our agent logic, something we can explore in another video. Now for this final section, we will look at using Claude Code, which is currently in beta preview, to add another agent to our existing agent process and run some specific tasks. As this is beta, this is likely to change as they develop this more. Some quick commands we can use. A good thing here is that we have a command to check current costs and see the token usage and related costs. For example, this is the current cost. We shall check this again after we have asked Claude to create our new C# agent. Let's initialize Claude to use our codebase. Now we can ask Claude to create a new agent, run our createagents.py file, open our updated knowledge graph web page, and finally show us the cost. Here I am making the request in the Claude Code shell to add a new C# agent and run our process. This is a simple request, but let's see how good of a job it can do. Again, I have sped up this part for the video, but it really did not take long at all. And now you can see the current costs. Wow, I really like this. Now we can check that our other agents were called back into action immediately and provided all the update documentation and knowledge graphs now that we have added a new agent and language type. Everything is looking good and Claude Code executed the instructions as we requested. This is AI building AI and exciting to see the possibilities. This is the end of the video, and I hope you enjoyed it. As I mentioned earlier, I am working on an enterprise version of this as a series, and once that is ready, I will share all the code and full how-to guides. Thank you for your time today. It really is appreciated. Have a wonderful day, and I will hopefully see you on the next video.